All right, I think we'll get started. We are expecting 9 or 10 more people, so we'll see if they join us as we go. But I don't want to start too late. So just want to make sure you can see my screen. It's the cover slide, and also see me. Can you see both of those things? Okay, great, thank you. So thanks for joining us today. We are talking about a topic that is growing in interest, seems like every day, in the field of contaminants of emerging concern, with a special focus on pharmaceuticals and personal care products. The reason I wanted to bring this talk to you and to other watershed groups is this field is becoming more and more known to the general public, and the public is learning more and caring much more about CECs. So I figured one of the first places the public would turn for information is not only to their municipality leaders, but also to the watershed groups. So we wanted to make sure that you had resources available to you to be able to answer difficult questions from the public as they learn more and more about this. The other side of my intent is to give you some information about sampling techniques in the event that your group is interested in growing into CECs at some point in the future. So this is going to be sort of a broad brushstroke of PPCPs, as much as we can fit in about 45 minutes or so. And we're lucky to have Todd Callaghan from the Massachusetts Office of Coastal Zone Management to talk to us about this today. Todd, I'm sure you recognize his name from some of your QAPs. He's been a reviewer of QAPs for many years now, so you've probably seen his name on your cover pages. And he's a wealth of knowledge on all things water sampling in the coastal and marine environment, sampling techniques, contaminants of emerging concern, and all sorts of other parameters that you might be interested in. And he does a lot of other ocean planning type work for CZM. And how his work tied in with CECs most recently is sitting on the OMSAP board. So that's the board of scientists that help advise MWRA's monitoring of the outfall pipe. So he comes at this with a lot of knowledge to share with us. Let's see. So quick outline of what we're doing over the next 45 minutes. Some background about PPCPs from Todd, as well as current monitoring efforts, both in the Northeast and on the West Coast. And then I'm going to jump in with an overview of sampling methods, and then we'll have a couple minutes for some Q&A. So with that, good. It looks like we've got some more people along with us. Good. So we'll carry on. And I'll hand it off to Todd here.
Thanks, Jill. Pharmaceuticals and personal care products is a large group of compounds and chemicals that includes prescription and over-the-counter drugs, veterinary drugs given to agricultural animals and recreational animals like horses, nutritional supplements. This is strange. I didn't really even think of this class until I started working on this, but fragrances, things like musk, are a very big component found in wastewater and in the environment. Cosmetics, including the antimicrobials that are in a lot of face creams and things like that. Those chemicals are frequently found. Sunscreen agents that we apply in the summertime here in the Northeast. And then various other household compounds, detergent, cleansers, toothpastes, anti-corrosive agents, etc. Next slide. How do we get these into our surface water? So everyone on the line today does some kind of monitoring, and we're all probably pretty familiar with sewage outfalls. But also recently we found out that many of these compounds can enter our surface waters through septic systems, whether they're functioning correctly or not. And I'll show you some slides in a few minutes, some research out of Cape Cod, where most of the sewage treatment is septic systems. Because it comes from human sewage systems, also illegal connections from sewage systems to storm drains will also carry these pharmaceuticals. Combined sewer overflows are a source in urbanized environments where we have sewage mixing with stormwater. And then also just anytime humans apply these things to their bodies, whether it's a cosmetic or a sunblock, and then we go into the water. Various researchers have detected UV blocking chemicals at recreational beaches, and so that's a emerging place of scientific research on how these things affect the marine biota adjacent to recreational beaches, but also paddling or paddleboarding, surfing, things like that. So basically, they get pharmaceuticals get into the environment because they're excreted through our urine and feces by humans and also animals, agricultural animals, especially in out west. They're disposed of down the drain, they're flushed down the drain, or they wash right off of our skin. Next slide. And so they're found in, or at least you could imagine they're found in freshwater estuaries, oceans, and sediments. And the research over the last 20 years has documented that. And I'll give you some examples again further on down in this talk. What's also very interesting is that these chemicals work their way up food chains and into the food web. So they're in the water column, they settle out of the water column, they get into the sediments, marine organisms and other organisms, if you're in freshwater, take them out of the sediments, incorporate them into their bodies, they're eaten and passed further up the food chain. And now we're interested, those of us who are working on the MWA outfall, we're interested in whether or not they're in the fish that we eat and in the lobsters and the crabs that we eat. We do not have answers for that at the moment, but they have been found in mussels, in fish embryos and fish livers, and in oysters on the Cape, as well as in marine mammals. Next slide. NUIPIC is one of the leaders in our region for water and water pollution and remediation. And they, in addressing pharmaceuticals and personal care products, have come up with this list of the types of things to be interested in. The source characterization, where are these chemicals coming from? How frequently do they occur in certain places? Is it only certain times of the year, for example, with sunblock or with pesticides? How do they transport from the source to other locations? And what's the ultimate fate? Do they break down over time due to ultraviolet light? Do they get incorporated into the environment through marine or freshwater organisms? How toxic are they? What's the risk to humans and to the environment? How do we rank them? There's hundreds, if not, there's thousands of these chemicals. I think there was 4,700 in May, and now there's like probably twice that. There's new ones being added to the list all the time. And then how do we remove them once we've made our list of, what's our priority list of top 5, top 10 we want to not have in our environment? How do we get rid of them? And finally, how do we prevent the pollution right at the source? One area within pharmaceutical disposal is how they affect the endocrine system, whether it's in humans or in animals in the environment. And you can see here from this diagram that there's quite a lot of different types of chemicals that can affect the endocrine system, the hormonal system in humans. And we're just starting to find out about that, and also about how it may affect embryo development and endocrine disruption in some lab animals. And we're not quite sure yet exactly what it might do further on up the food chain. Some of the folks that I work with are concerned about North Atlantic right whales, of which there's only about 400 left, and they're in the Northeast and the Eastern Seaboard, and with all the wastewater outfalls dumping pharmaceuticals and chemicals into the ocean, is that affecting them? Or is it affecting their food supply, which then affects them? Next slide. Some other considerations. There's a vast number of chemicals and they behave differently. And so how these chemicals are structured, how they behave chemically determines how well they're transported from one place to another and where they end up. Some end up bound to the sediments. Some are in the water column. Some are at the interfaces of sediment and water. And then some bind well to fats. And so they're found in organisms that have fatty layers. Another thing to be interested in is that around wastewater outfalls, a continuous discharge may result in what we call pseudopersistence. So pseudopersistence is that you continually see the signal of these pharmaceuticals in a location, in a river, for example, even though these things disperse and the chemicals disperse and are diluted. Because the discharge is continuous, you always get the signal there. And I'll show you some examples from the Hudson River in a few minutes. Right now, the pharmaceuticals are not regulated by EPA, and under this climate of the presidential administration, we're not likely to see it. And so a lot of what may happen will be at the local level, meaning at the state level of regulating pharmaceuticals. We do know that the residues from pharmaceuticals, so what's left after we metabolize part of it and excrete it, that they're pretty much everywhere. They're found in fresh water, in salt water, and they're found in sediments. They're starting to be found in animals. But the levels we're finding them at are parts per billion, parts per trillion. So they're not at the therapeutic levels. They're not at the levels at which we would expect them to have the effects that they would have if they were being taken in a way such as in medicine, in a pharmacological way. And then they may have different patterns. So depending on which chemical you're looking for, you may want to focus your effort either in the summer or the winter. For example, you find sunscreens and pesticides in the summer, but you're not likely to find them in New England in the winter. Next slide. The effects of these chemicals can be detected at very, very low concentration. Talking about parts per million, parts per trillion. The inset on the right here shows a list of some contaminants of emergent concern with no observed effect concentration. So that's an official EPA term, NOEC, no observed effect concentration of less than a tenth of a part per million, or 0.1 milligrams per liter in fish. And so there's a whole list here at fairly low levels. And this obviously makes testing for them very difficult. And it's only in the last few years that changes in technology and instrumentation have allowed us to find these chemicals at all. And so now we're realizing, hey, they're everywhere in our environment. We need to start understanding if they have effects. And again, and the effects are very difficult as well. It's also difficult to find them in time and space because unlike some of the things we're used to sampling for, say, for example, bacteria, which is difficult enough. Anyone who's trying to find a signal for bacteria in a river knows how difficult that is. You got to really identify the location and the volume we take that you're very familiar with as volunteer monitoring groups is 100 milliliters. With these types of chemicals, with pharmaceuticals, we're talking about 1 to 2 liters of water per sample. So it gets, the volume's pretty high. And these chemicals are not frequently toxic, but they have chronic effects, and they affect development, and they have behavioral effects we need to better understand. Next slide. So here's some of the known effects. Triclosan is an antimicrobial that apparently is found in, or was found in many different things. It's been banned since 2014. It is still found in the environment because it was widely used, but it was in cosmetics, it was in toothpaste, it was in a number of different things that we used as an antimicrobial. And so some work has found that it causes mortality in zebrafish embryos, also endocrine disruption in fish, and a few human health issues. And that was reviewed by these two folks, Giuliano and Magrini. That was a literature search that showed a number of different effects from the worldwide literature on triclosan. Sheridan et al. Found reduced benthic diversity due to triclosan in mesocosm experiments. So those are large tanks that mimic an ecosystem, and they pumped in water that had triclosan in it, and they were able to find changes in benthic diversity. That's not saying it was good or bad, but definitely there were changes. Ishibashi et al. In Japan found induced mortality in the local fish. And then there was also induced mortality from triclosan in shrimp and phytoplankton. I believe that was in South Carolina by Di Lorenzo et al. But those levels were at levels much higher than what's found in the environment. So that's an interesting point, is that often in order to find effects, we need to dose the organism of interest at levels much higher than what these chemicals are found at in the environment. Magnesium lauryl sulfate, which is an ingredient in cosmetics, was found to inhibit sea urchin egg development. So that's another marine developmental issue. Titanium dioxide, which is an important chemical in sunblocks, affected muscle digestion and immunity. That was in Barma et al. And this fragrance, galaxolide, apparently is found pretty much everywhere, because I've found a number of studies on that. It's a synthetic musk, and it was found to affect copepod survivorship and life history. So the development, in that case, I think it was the number of offspring produced by females. But again, I think that study needed very high levels that were much higher than are found in the environment. Next slide. So closer to home, what are some of the local groups doing in terms of monitoring for things, contaminants of emerging concern? Part of my work, as Jill said, is to help advise the Outfall Monitoring Science Advisory Panel for MWRA on what should be monitored at their outfall or any other special studies. The MWRA, in its outfall in Massachusetts Bay, looks for legacy contaminants, so things like pesticides, PCBs, PAHs, all the typical things you might expect from a wastewater outfall, nutrients, solids, bacteria. And they also do some special studies looking at some legacy contaminants in fish and lobsters, looking at PAHs and pesticides, metals. In terms of pharmaceuticals, what we found is that no, the MWRA does not look for them, has not looked for them. So this is an area where we're looking to maybe have them do a special study. And that's pretty telling. So even though research on these pharmaceuticals has been going on for 20 years, and we've known for at least 5 or 10 years that they have effects on marine organisms, and this very well-funded program, they spend $1 million a year on their outfall monitoring, does not monitor for PPCPs. So this is sort of a caution for you as volunteer monitoring groups with much smaller budgets, that PPCP monitoring is very expensive, especially since the specialized lab and instrumentation, but also the huge volumes of water that need to be processed, 1 to 2 liters per sample. Next slide. Again, what are some others doing? Laurel Scheider from the Silent Spring Institute worked with the Provincetown Center for Coastal Studies to look for pharmaceuticals and other contaminants of emerging concern on Cape Cod. And they looked in estuaries, in marshes, and they also looked in some oysters. As you may know, there's a lot of oyster farming on Cape Cod right now to reduce nutrients in the water column, and people are eating these things. Well, they're also eating the contaminants that come out of their wastewater. Most of the wastewater is treated by on-site septic systems on the Cape, and that does not necessarily remove pharmaceuticals and other contaminants of emerging concern. So that goes through the groundwater, ends up in the estuaries, and being detected in the oysters. So you can see here that program detected 13 different contaminants of emerging concern in the water column and 10 different contaminants of emerging concern in oysters. And what I've listed are some of the pharmaceutical and personal care products: an anticonvulsant, antihypertensive, some nicotine products from people who smoke, insect repellent, some estrogen hormones, antibiotics, and antimicrobials being found in the oysters that people eat on the Cape. Next slide. About a year and a half ago, the Massachusetts Department of Environmental Protection advised the OMSAP group on some of the things that they were interested in at outfalls or wastewater facilities. And they came up with this top 10 list of contaminants of emerging concern. And you can see that pharmaceuticals and personal care products are on that top 10 list. Many of you have probably heard about PFAs, polyfluorinated alkyls. That's taken the #1 spot. That's not even on this list, but that's the #1 spot right now for DEP. And pharmaceuticals, honestly, are not really on their radar at all. I just did a quick look at some of the grant programs, and as far as I know, the 604, 3B, any of the other volunteer monitoring programs are focused more on bacteria and sediments, basically the traditional stormwater pollutants coming off of stormwater. And so at this time, it doesn't appear that the MassTV grant program could fund any pharmaceutical work. Next slide. Okay, so the next few slides may be a little confusing, so I'll talk you through them. There's a lot of information, but as part of my work trying to advise the MWRA, we looked at the most robust monitoring program in the country is in Southern California through a group called the Southern California Coastal Water Research Program, STCWRP, we'll call them SQURP. And basically they are funded through a certain amount that each of the large wastewater outfall contributors in Southern California pay to the SQURP group. And they do really significant, very good research. There are many, I hesitate to say dozens, but I've noticed at least 10 or 20 researchers are funded by this group. They put out very good, understandable, peer-reviewed reports. And basically, they're trying to address many of these contaminants of emerging concern, both in freshwater, in drinking water, in estuaries, and in the ocean. And they're looking at all the things we talked about before, the sources, the fate. Are they getting into food organisms? Are they in the sediments? Are they in the water column? And basically, they boiled down these thousands of chemicals down to a list of 82 based on what labs could detect. So a commercial lab can only detect about 82 of these thousands of chemicals. Next slide. And they came up with a process for identifying a shorter list, which I'll show you in a few seconds. But first, I want to show you some of their results. So the next few tables you'll see are results of some contaminants of emerging concern. Not all of them are pharmaceuticals. So I've circled in red the ones that are pharmaceuticals that have been found in different types of environments. So this table shows the contaminants of emerging concern that were found in ocean sediments. And I guess I should have circled acetaminophen, that's at the top, but it wasn't found in either ocean or estuary. So on the left, you have the compound of interest. In the middle two columns, whether or not it was found in the ocean or in the estuary, those are in parts per trillion. And then the reference of where it was found. And you can see some of these citations are fairly old now, so 10, 15 years old. So the literature has been building on this, yet it's only recently that people have become interested in it. But what you see very frequently are things like carbamazepine, which is an anticonvulsant, diazepam, which is an anti-anxiety, anti-seizure, and triclosan. I see those in a lot of different lab studies and a lot of different environmental studies. So these things tend to stick around in the environment. Next slide. And so this slide shows a table of contaminants of emerging concern that were found in various biological tissues. Across the top of the table, you can see the different classes. Fish liver, an ocean fish liver. So I think that was something they call the horny head turbot, which is a type of flounder. Estuarine fish, freshwater fish, pinnipeds, which are seals, mussels, which are very good at assimilating things in the water column. So you'll see a lot of different chemicals in them. And then bird eggs. And in that case, I think the birds were cormorants. And so what I've circled are the various pharmaceutical personal care product compounds that were found. Very few were found in the ocean, which was good news for us who studied the marine world. But a lot of these were found in mussels. And I can't remember, honestly, if they were, I imagine they were saltwater mussels, but we do have freshwater mussels also, as some of you know. And on the right, I've listed some of these chemicals and what they're used for. So again, antihypertensive, anticonvulsants seem to be found very widely in the environment. Doesn't matter where you're looking, they're being found. Stimulants are found, and antibiotics are found. So these are the things that tend to be found at the highest levels and most widespread. Next slide. As I said, the SQURP went from thousands of chemicals down to 82, devised a process for winnowing that 82 down into a top list of, first of all, chemicals that could be detected. Secondly, chemicals that they did find in the environment. And third of all, chemicals that had a certain risk factor associated with what they call MTQ, or there was a monitoring risk quotient. And basically when the quotient is greater than 1, that means that it's found in the environment at a level that's above the level that we know where it has effects. So if it has effects and it's in the environment above that level, then we should be concerned about it. And so in this table, what the SQURP has summarized are 15 compounds on the left, and then various places where they believe they should be monitored for. Inland water bodies, so across the top in the dark green bar, inland water bodies, embayments, in wastewater effluent, in freshwater streams, in embayment sediments, in marine sediments, or in organism tissues. And so if there is an M in that column, that means yes, that should be monitored for. And then if there's an E or an F, that means you should look for it in an estuary or in fresh water. If there's an O, you should look for it in the ocean. So for those of us who are interested in the ocean primarily, go ahead. For those of us who are primarily interested in the ocean, there are no O's there, so that was very good. That meant that the ocean produces a lot of dilution, and we really didn't need to be too concerned about monitoring these things. But for the ones I've circled, these pharmaceuticals, estrogens, ibuprofen, galaxolide is the fragrance, diclofenac is also a anti-inflammatory, just like ibuprofen, and triclosan, the antimicrobial. So these are the things, if you were interested in monitoring, this is what another group came up with and said we should be interested in monitoring in an estuary or in freshwater. Next slide. The Squirps conceptual model, again, if you were interested in modeling, you might want to take one of these 4 bins, if you will, and think about, is this something that my monitoring group can help with? First of all, screening. What's in the sewage? What's in the environment? So there's been some work recently where folks can use cell assays. So certain single cells are programmed to detect these chemicals, or you could use a certain type of passive sampler. And we'll talk a little bit later about that with Loretta Fernandez from Northeastern is interested in working with folks. She is a specialist in passive sampling, and basically passive sampler works just like a mussel does. You put it out in the environment for a bit, it integrates the chemicals it interacts with, then you bring it out of the environment and you're able to release those chemicals and find out their concentrations and what was there. The second bin here is what's the biological relevance? This might not be the realm that many volunteer groups go into because it involves a lab and toxicity tests, but it's something that needs to be done at some point. Are the pharmaceuticals in biota? Now here's something maybe volunteer groups could help with. As Jill and I were talking about earlier, often a researcher at an institution will get money to do work, but they need bodies and hands on the ground. They need local knowledge of where to go to get that fish or mussel, how to get to it, who has a boat that I can borrow for a day and not spend $10,000 of my grant, paying for that. And so that's where I think some volunteer groups might be able to help in terms of the field work. And then lastly, and I think Jill is going to speak about this, what are the actions to protect human health? What's the outreach that we can do to help at the source prevent these things from getting into our environment in the first place? Next slide. So now the next few slides, I'm going to show some work that came from Mark Cantwell, pharmaceutical researcher at the US EPA in Rhode Island at the Office of Research and Development. He's done a lot of work in the Northeast. And I'll show you right here on this slide, here are 9 different pharmaceuticals. So there's 9 boxes here. On the left axis for each is their concentration. That's in parts per trillion. On the y-axis is the distance on the Hudson River from upstream at Albany down to the mouth of the Hudson River. So that's river kilometer on the x-axis. And then what you're looking at are 2 different time periods, May and July. So that's what the lines are. And you can see for each of these, so just look at the first box in the upper left. That's trimethoprim, which is an antihypertensive. Many of these are antihypertensives, actually. And one's an anti-anxiety, and then acetaminophen, is anti-inflammatory. But just look at the upper left here, trimethoprim. What you see is that it's at fairly low levels, 8 parts per trillion. And then you get these spikes. And so those spikes are the pseudo-persistence that Mark had spoken about and that I co-opted and put into my slide earlier. These are the locations of outfalls, large wastewater treatment outfalls into this freshwater river, showing spikes. And you can see there's a bar there that interrupts the Y scale because it goes quickly from single digits parts per trillion into hundreds of parts per trillion. And you see that same pattern throughout pretty much all of these chemicals going from left to right, from upstream to downstream. So again, if you are a volunteer group looking to find these things, focus around wastewater outfalls or places where you think there might be most concentrated. Next slide. In Long Island Sound, again, something very similar. Let's just look at the insets on the bottom. The map on the left, all those dots show where Mark sampled in Long Island Sound, going from the west, closer to the Hudson River, to the east, where there's more flushing. Then if you look at the middle inset on the bottom, it's called pharmaceutical concentrations. Each of the colored bars within one column is the concentration of a specific chemical. Most of those are antihypertensive. One is an anti-anxiety, carbamazepine. Again, it's in parts per trillion on the y-axis, and the x-axis is the location of the sample. And basically what this shows, again, is that when you get closer to a source, in this case to the west is the Hudson River with a lot of wastewater outfalls, the levels are higher, and as you go further to the east, there's mixing with the ocean and dilution, and the concentrations are lower. Next slide. Oh, one thing also from that last slide, what they found from that research was that sucralose, which is a fake sugar used as a sweetener, is a very good indicator of many of these compounds. And so another interesting thing to learn in monitoring is, well, if you can find sucralose, then you have a really high likelihood of finding some of these other chemicals. And so this slide I borrowed from Anna Roebuck, who is a PhD candidate or maybe a postdoc at this point at University of Rhode Island. She works very closely with Mark Cantwell from EPA and other researchers. She grabbed these samples from Massachusetts Bay near the MWA outfall and found this relationship. So on the x-axis is the concentration of the, I think it's sucralose on the x-axis, and then the concentration of the chemical of interest on the y-axis. It's in parts per trillion, and you can see really close relationship. That's what the R squared means. When you get an R squared of 0.9 or higher, that's very, very high. So basically, any of these chemicals could be indicated by the presence of sucralose. So somebody could go out and look for sucralose and have a good idea that they have. It'd be a good screening tool to see if there are pharmaceuticals in your water. Next slide. And in Narragansett Bay, this is also Mark Cantwell's work. This is just interesting to show, again, there's 9 chemicals. Again, we'll go look at the upper left, metoprolol, which is a antihypertensive. What these aggregations of columns are showing is on the x-axis is time from May 2014 to April 2015. So we're looking from left to right, a time effect. On the y-axis, again, is concentration in parts per trillion. And then going from closer to you to further back, actually, we'll start. Further back is up bay, closer to the cities, closer to the freshwater. And closer to us on the screen are the values that represent locations closer to the ocean. So for just about all of these chemicals, except for caffeine, you can see that they are higher near the freshwater source, near the cities, most likely near the CSOs and the wastewater outfalls. Caffeine is found everywhere. So you probably don't want to look for caffeine in your volunteer program because it's not going to tell you a whole lot. It's found all over the place. But some of these things can tell you, what these patterns are showing is that closer to the freshwater source, closer to the wastewater outfalls is where you should be looking. Also, some of these have a temporal signal. So the bottom rightmost set of columns, gemfibrozil, which is also an antihypertensive. For whatever reason, that one did really well in the spring of a particular year. I don't know why. Next slide. And then lastly, really close to home, here's some samples from places in Boston Harbor. And really what, I guess 2 things we'll take from this. One is that there's many non-detects, which is good news. And then some of the things we can find, again, are the antihypertensives. Look on the left column, about a third of the way down, atenolol and metoprolol. Those are both antihypertensives. And then second from the bottom, hydrochlorothiazide. That's an antihypertensive, and that's highest in the Charles River. I don't know why it's so high in the Charles River, twice as high as some of the other places. I don't know what the error bars are around this sampling, if that's a real high or just an error, within the error bounds. But that's just something to note, that some wastewater outfalls might have higher concentrations of some of these chemicals based on the population. Interestingly, some places on the Cape, we see really high chemicals that might be associated with people who are older. And you look upstream, and then there's, like a nursing home. And so it's no surprise that the nursing home's septic system is leaching these things out into the local embayment. And again, the second row, if you look on the left, caffeine, that's everywhere. So don't look for caffeine in your program. Next slide. So there's a lot of information, but I'll summarize it this way. We can find the pharmaceuticals in water, we can find them in sediments, and we can find them in biota. But in all cases, they're at very low levels. We're talking parts per billion and parts per trillion. Normally, when we measure things in the environment, they're in the parts per million or parts per thousand level. So these are billions and trillions. There are a limited number of studies that suggest some risk to human health in biota. But for ocean outfalls, it's very, very low. It might be a little higher in freshwater environments, especially, I would caution, in places where not only is the freshwater a source for where discharge occurs, but also where drinking water occurs, like, for example, the Merrimack River. Even though we don't know their effects, that doesn't mean there's no harm. It could be that we just don't understand the true effects yet because we're trying to get up to speed with these low levels of chemicals. Good news is that some chemicals like sucralose are correlated with pharmaceuticals, so they may be an option for monitoring. Passive sampling is a good option for monitoring. And lastly, this comment came from Mark Cantwell at EPA. Anyone who does any work should focus on chemicals that are persistent, bioaccumulative, and toxic, PB and T. And what we've found so far is that, yes, we may have persistence in some of these pharmaceuticals. Some may have some toxicity, but there's really, I don't think there's any evidence now at the moment that they are bioaccumulative. We know that they can be found in biota, but for pharmaceuticals, there isn't any research that I was able to find that they are bioaccumulative. On the other hand, there are other contaminants of emerging concern, for example, PFAs, which are PBT. We know they're bioaccumulative. And there's a number of other things too, PBDs and some other things. Next slide.
That's great. Thank you so much, Todd. In a couple minutes, we're going to have a chance to discuss some of the things Todd mentioned and ask questions as well. But I just want to first, briefly describe what I've found that watershed groups can do. Starting with education, encouraging your communities to utilize safe disposal practices of unused medications. There are a lot of different disposal locations now. They're at many police stations, fire department buildings, and even now in CVS and Rite Aids now. So folks just need to know where to find those and really what they're used for. And then also educating your communities on the use of sustainable products. I wish I could have a list for you of what those sustainable products are, but the things that come to mind are, not using facial washes with microbeads, things along those lines. And I'm hoping as this field gets more and more attention that people will have a place to go to find out what products really are the most sustainable. Staying in tune with research, knowing the latest trends and techniques is something we can all do. And really the focus here for the next couple slides is monitoring. So if your watershed group is interested in monitoring, you can use targeted studies where you're out sampling, specifically looking for different compounds, or the passive sampling in the field and using indicator drugs where needed. So Todd mentioned the SQUERP. We saw this table already, but I just wanted to point out those first two columns would be the most relevant to the groups on the line for freshwater inland water bodies and then embayments. So you can see there, anything with an M next to it, it is a compound that's recommended to monitor. And then if you're wondering where would you even begin, SQUERP also in their report, this is in Anderson et al. 2012, they have some guidance on where to even begin with developing your pilot study, all the way down to how to select your sites and what kind of sampling design you would want to do, sampling frequency, questions along those lines. So those are resources for you if you wanted to take those steps. In terms of the actual fieldwork, the procedure for surface water sampling is not unlike what you're all used to anyway. It's 1 liter sampling though, or more, as Todd mentioned. So you're sampling that in amber glass jars, keeping it chilled until delivered to lab within 9 days. So you have a lot of time there to get samples to labs. USGS is currently looking into using frozen samples, and if that's an option going forward. A very small aliquot of that sample is taken for solid phase extraction, and then pharmaceuticals can be quantified going through liquid chromatography mass spec. And there are methods for at least 100 pharmaceuticals at this time. A note though, labs are prohibitively expensive for sampling PPCPs. At the advice of EPA and other scientists in the area, like Amy Costa at Center for Coastal Studies, the advice is to seek out academic or government partnerships for this, rather than going to a commercial route. I tried to get some costs, some actual price tags in preparation for this talk, but wasn't able to find them. But from what I hear, it's cost prohibitive. If interested in passive water samplers, these are pretty neat. USGS developed these polar organic chemical integrative samplers, or POCUS. They're basically thin membranes that are deployed in a variety of configurations, but they tend to be in some kind of canister that's then floated for 30 to 40 days. There's a picture there on the right of what a canister and membrane setup might look like. And then those membranes and holders are shipped overnight to a lab, and again, processed with LC-MS. In sediment, PPCPs can be sampled just by using a simple Van Veen grab for the upper 2 centimeters of sediment, and then sieving that with a 2 millimeter screen to remove any debris and gravel. The sample's frozen and shipped on ice to a lab, and this undergoes solid phase extraction and then gas chromatography and mass spec. If you were interested in developing a program or getting your feet wet with this type of sampling, we can't stress enough how important it is to find a partnership, and there are people in New England doing this work, and some are open to partnerships currently. So these are some of the contacts you would want to start with. Some are more local than others. And I did speak with the bottom contact there, John Morrison, the USGS National Water Quality Lab, Massachusetts Water Center. They are interested in these partnerships. They can process the lab samples there. That's how the Center for Coastal Studies did their work. So it's at a much reduced rate. And then USGS benefits as well as the watershed group. Just some resources. I will send out this PowerPoint so that people can click on these and find out more information. The bottom one there is great. It's a YouTube channel that's dedicated to PPCP, so there's all sorts of interesting videos there. And now I'd like to hear questions that anyone might have, but also I'd like to hear if any of your communities are talking to you about this already. Are they requesting that some action be taken? And are you thinking about adding this type of monitoring to your to all the other busy work that you do? So I'll open it up at this point. You can feel free to chime in. There's a small enough number of us. You could just chime in by voice. And I do think we had one question in chat. You're also welcome to just write a question in chat. So Sherry asked if about titanium dioxide having an effect on organisms. Which organism was it? And I heard that it's reef safe. So wondering how, where the disconnect is there.
I don't recall what the organism was, sorry.
Yeah, we can find that.
Check.
Muscle digestion and immunity. So again, Sherry, this was probably in concentrations way outside of what would normally be measured in the environment, in the ambient water, I'm assuming. Todd, do you know, was this more of a microcosm?
I actually don't remember that one.
That's a good question though, because those reef safe sunscreens and sunblocks, are touted as being a much safer option for marine life. You're welcome. No problem, Sherry. Oops. Any technical questions for Todd?
I was just looking quickly if I had that citation, but I don't have it. I'll just add, for people who are interested, I did speak obviously to Mark Cantwell, and he has an ongoing program at Narragansett Lab, US EPA. Anna Roebuck is one of the people working with him. The University of Rhode Island has a large federal grant right now to look at contaminants of emerging concern. And so they will be looking for folks to work with. Also, Loretta Fernandez, I've spoken with her, and she is eager. She's working on a grant right now and be eager to work with folks in watershed groups for exactly the reasons that I said. So Loretta's at Northeastern. She doesn't have a boat. If anyone has a boat, or even if you just have your local sampling location that you access with a pole and a 1 liter water bottle, that could be really helpful to a researcher to have that knowledge on the ground and say, here are 3 places in this watershed where you're most likely to find these chemicals, or here's a place where you should put a integrated sampler and float it there for a while.
That's great. Sherry is in the chat box because she doesn't have a microphone, but she was saying that she has been approached by community members about these concerns, but not by municipalities yet.
If there's any good news, the good news is that it appears that these things only have effects at very high levels that are above what we're naturally finding in the environment.
Right.
So that's good news at the moment. And I think many of us are turning our attention to things like PFAs and PBDEs. DEP is very interested in PFAs at this time.
Oh, great. Yeah, Sherry said she samples 8 estuaries. She has a lot of boat contacts around Martha's Vineyard and would love to work with and collect for a researcher. That's great. Since you brought up PFAs, Todd, our next call next Wednesday, we're having a talk with David Robinson. This will be really interesting from the Board of Underwater Archaeological Resources, giving us just tips on what to look out for in terms of archaeological resources in rivers, streams, embayments, and marine areas in case we come across them during fieldwork. So that'll be neat. But then the following week on June 24th, also a Wednesday, we'll be talking about PFAS. So I think the public is probably a little more aware of those contaminants, and you might be hearing a little bit more noise from them in terms of that. But if there aren't any more questions on this topic, we can close it, and I will send out a PDF of this PowerPoint as well as a link to the video recording. And I appreciate y'all being here. Our emails were on that front page, the first page of the talk. So if you have any questions that come up after the fact, just get in touch with us. Anything else from you, Todd?
No, that was great. Thanks, Jill.
All right, thanks, guys. Enjoy your week. Bye.